Hi everyone. Today we're going to be talking about finding the voice of the customer through various integrated data sets. I'm Sierra Duncan. I'm a business analyst for Disney. A lot of the work that I've done here at Disney has been focused on understanding the voice of the customer, which is what we're going to talk about today. We're going to talk about understanding the voice of the customer, utilizing integrated data sets, because if you're not listening to what your customers are saying, you're missing critical data points that can help you drive your business forward. All right, so the reason that we're all here is to kind of look at what information we can glean from what our customers are saying. Customers are constantly interacting with your business through a variety of channels. This data can be incredibly powerful in providing insights as to how your customers view, interact with, and experience your product. Some of the key data streams we'll be looking at today are perfect examples of that. So to start off with, we're going to cover some of these three main topics of customer service data streams. Data from your CRM can give you insights into what your customers are experiencing, maybe with a feature, or maybe they're experiencing a problem. Diving into these metrics on their own can be very powerful in understanding what's not working for that customer experience, but oftentimes customers, if they're experiencing an issue, they're not reaching out to you directly. Oftentimes, they're going to social. Data from social listening can be invaluable to understanding the voice of the customer, because in the social media world we exist in today, product awareness, sentiment, and trends can drive an incredibly powerful impact to your business. How people are talking about your product and peers is no longer word of mouth, but captured in an incredibly rich data stream that can be used in conjunction with the third data stream that we're going to be talking about today, which is direct customer feedback. What are your customers telling you? This type of direct response is often bottom of the funnel, and if you're getting direct feedback on an issue, it's typically a more pervasive issue than what could have been identified earlier if we had looked at all of that data in conjunction with one another in a single cohesive data set. It's all well and good to have analysts on various teams looking at these data streams, but they don't tell a cohesive story that the customer is trying to tell us when the data is siloed within various tools and data sets. Pulling these data streams into a single data set allows us to gain that full picture of the voice of the customer. Having all of that data in a single data set makes perfect sense, but logistically, this can be quite a feat. Regardless of if you have a tenured business or a rapidly growing startup, your tech stack is likely going to give you some challenges when trying to synthesize these data streams together to form that elusive, centralized data set. The first and most obvious challenge is number one. The data from various data sets is in a completely different format. How can I format them into just one single data set? There are inherent obstacles that come up when trying to take that into consideration, but careful planning and structure can make having that single data set attainable. The second challenge is, how do I build for scale? Especially when there are constant changes with the data, this is a challenge. Taking the time to structure a data set would feel incredibly draining if there's constant patching and updates needed. Building for scale is critical because your data set is not going to be useful if it's not accessible. Which brings us to our third challenge. How do I make a data set that's most usable for my audience? The goal of having a single data set is that you can have a single source of truth so that Jane from marketing and John from customer service are all seeing the same exact data and can draw the same insights and conclusions at a fast and easy pace. The first thing that you're going to want to do for this, when you're connecting these various different data sets, much like you would for any kind of storytelling, is understand what that through line is. Once you understand that single through line that needs to be driven through each one of your data sets to connect them together, you'll have a better understanding of what you need to do in order to get that into a single cohesive data set. So first, we talked a lot about these different types of data streams originally, and so what we're going to cover today are some key examples of what these actually look like. As I mentioned, we're looking for that through line. So for today's example, we're going to be looking at a new feature. Let's say your company has launched a new feature that you want to go and take information from your CRM, which is your help request, your operational performance data. You want to take data from your social listening, so you want to understand sentiment. You want to understand the trends. You want to look at mentions that are happening. You also want to take some of your direct customer feedback. This is going to be some customer satisfaction, some feedback forms, product surveys. Taking all of those pieces of information together will help you understand what your customers are saying at various touch points within the customer experience. Now we're going to go through and address that first challenge that we talked about, which is connecting the data. So let's say, for example, you have these 3 different data sets that you want to look at, but the data format doesn't necessarily work. Oftentimes there's one-to-many ratios. So for example, if you have CRM data, you're going to have multiple customer rows, but you don't necessarily want that. You want that into one single row. And so that is a common issue that customers will have, which is addressing the one-to-many. Also, we're going to go through and talk about countries versus country codes. Oftentimes when you're parsing together feeds from different data streams, some data sets will handle countries as a country code versus the full spelled out version of that country. In addition to that, one of the other aspects that can be really challenging is going to be naming conventions. While they may be consistent throughout, having it in a single format will make it much more easy for you to break your information into one single data set that makes sense. Our through line that we're really looking for here is our feature. And so taking that feature idea as a through line, we're going to go in and connect a single row of data for each day that shows us what the app rating is, and if it's changed, which ideally we do want that app rating to change. We want that to go up if we've assisted the customer and they've been able to get a better idea of their feature or their product. What we're going to do here is we have our basic rating change data. So this is just the same data flow that we'll have here. And basically what we're going to do is we're going to take this new data and our old data, and we're going to compile it into one single row. So we have 2 challenges to deal with here. We have the recursive data flow aspect, which we'll get to, but then we also have the idea that, okay, so we have, not only do we have multiple rows, but we have the updated version and the original version. So how do we get that into one single row? Well, first and foremost, we're going to do an append. So we want to get all of those rows of data into one single row. And if we do a quick preview of our data, we can see that we have a rating ID, and that's going to be our unique identifier that we're going to use. Now we're going to use this really useful tool called Rank in Window. Rank in Window allows us to do a variety of different things within Magic ETL. Namely, what we're going to use for this is it gives us the ability to do a lag lead. For this, as I mentioned, we wanted to append our rows together, and so we've done that, but now we want to say, okay, great, now everything is stuck together, but they're not necessarily sorted in a way. We can see these are all the different rating IDs. None of them are linear. And so what we do is we sort by updated date. We're sorting by updated date so that it gives us all of the information split out by rating ID, which is a partition. It gives us, in an ascending order, our updated date of the different aspects of data. So if we look here, we have our rating ID of 1 and 1, and we have, in this top row here, we can see the rating was 3, the updated number is 3. There were no major changes there. If we're looking at this one, we have a rating of 2, but it was updated to 3. And so we have in that single row what the rating originally was and what the new rating is. And we did that by setting up a new field, which is a new function here, updated rating. Using the lead function, we can say, okay, I want to look at the rating field and offset it by 1. And we'll hit apply up here. And the reason we use lead is this is updated date ascending. And so what that's going to do is each one of those rows that we're looking at, it's sorting by ascending. So your first row is going to be your original data set number, and then your next row is going to be the updated number. And then we can say, okay, great, we have this is all set, this makes sense to me. So now what we want to do is we want to go and remove duplicates because we have multiple rows of data here. So we'll simply go here, put in our parameters for removing duplicates. As I mentioned earlier, our unique identifier is going to be rating ID. So we'll go through here, remove duplicates, and what that will give us is it gives us this updated number. And as I mentioned before, we were looking at rating 2. It gives us the original rating and the updated rating. So now we have this information all in one place, and we're able to use this using a recursive data flow. When connecting these with live input data sources, you can actually keep this running so that as your data updates, you will have that refreshed data source. Now, in addition to that, one of the challenges that we're really looking to address is going to be the one-to-many ratio. So this data, it's all well and good. We have, multiple pieces of information here, but I can't really use this yet for my main data set because I'm not quite at that through line state yet. I still have a lot of rows that really need to be condensed into one. And so this is where using group by is incredibly useful. Pulling over our group by. Now, anyone that's familiar with using a pivot table, group by will be something that's really inherently intuitive for you. So what you can do is we can go in here and identify a grouping. So as I mentioned, really looking at this data, our through line is going to be our feature. And so what we want to really do is we want to put in all of these different breakouts. Now we are going to do a created date. That is an element that's going to be part of our through line, but we're mainly going to be really looking at our feature. And so that feature is going to be something that we want to really break out. The rest of this information is really helpful, but it's not necessarily useful for our main data set that we're really looking to put together. So we can really just split it by these two aspects for the purposes of this. So identifying these allows you to see what the breakout would be. If I just did feature tag, I would end up getting 3 rows because I have 3 unique values here. I have feature A, feature B, and feature C. Utilizing the created date there as well gives me a different row for each created date. So I will have data from the 24th and the 25th, and I will have 3 rows for each one of those feature tags that's associated with that day. Now, going down here, this is really where we're gonna pull in that information that we really wanna look at. So first and foremost, we have to name it. So what I'm technically gonna do here is I'm gonna take all of the ratings that are shown up right here, and I want the average of those. Because ultimately, what I want to be able to do for my end result, I want to be able to understand what that average change looks like. And one thing I do want to note is that because of the way we set this up, even if there was no change, we'll see an updated number here. So there's no concern that we're going to be missing pieces of data. So I'll go in here and I'm going to type in original rating for our example. And we're going to use rating there. And what I'm going to do is I'm actually going to do an average. I'm actually going to call this app rating so that it's super clear when we're putting this into that big data set. And then this is where we're going to call our updated rating. And we're going to use the updated rating. And we're again going to take an average. So I'm just going to hit a preview just while we connect this. And then you're just going to name your data set to what you are looking to call it. And I'll call this app rating data just for the purposes of scalability. Now that we've taken our data and grouped it together, we now have single rows of data that encompass multiple different pieces of data into one single row. We now have the ability to take this piece of information, which is our app ratings, and the changes that the customers have been able to make to those based on the interactions they've had with customer service, and understand how those app ratings have changed. This is really useful for us to look at and understand, okay, these are issues that we've been able to assist that are both customer facing, meaning that they are app reviews, as well as we can see what our customer experience team has been able to do in order to make that customer experience better. If you're an existing Domo user, this is a way that you can utilize Magic ETL to really take your app rating data and get a better understanding of how those changes are happening and flow it into that main customer data set that we're really looking to come up with today. if you don't currently use Domo, really what like entices you into using it. Like, I mean, taking this data and putting it into a single data set is something that's really challenging when you're trying to do it in like Excel, or when you're trying to do it in really like any kind of outside format. But utilizing Magic ETL, you can process it so that it is scalable, and you can then take that data and put it together with your other pieces of data to understand what that full picture is. It's much easier when you're able to control that back-end process rather than having to do it each time in Excel. All right, so now we have our app rating data, which we've taken just as a review. We've gone and taken our original data that we were looking at, which was broken out into each individual rating, which we actually had twice because we had our original rating, and then we had what the updated rating was. And we've been able to condense that into 6 single rows of data that we can look at here by day to understand by feature, which that feature again is our through line. We can then take that and look at what that app rating change looks like. Taking that into consideration is going to be really helpful as we look to understand how our features are performing by what the customers are saying in app ratings and app reviews. Okay, so we've gone and taken a look at grouping and how we can take those individual pieces of information and put them into one single row so that we can really flow that through line. Now, one of the challenges that we're going to come up with is if we're looking at different data sets, oftentimes there's going to be country codes and naming conventions that are going to be really challenging for us to address. Now we're going to take a look at some social sentiment. So for the example here, we have our output from a social listening tool, and we can look by handle what the sentiment score is. Now, this is a great example of how we have data here that is really rich, but we can't necessarily parse it out on its own without utilizing another tool. So using Domo's Magic ETL, we're actually going to go through and use this handle and break this out into a usable format. So one thing that is super helpful is the replace text option. We're going to be using both replace text and split column here. So in this example, we're going to use handle. And if we're looking at our original data, back to that concept that we were thinking about before, which was really looking at, okay, what do I want my final data set to look like? We can take this information here and say, all right, so I know that I want to be able to parse out country here, because maybe that's something that'll be helpful for me. And then I always have help here, but that's not necessarily something that's useful for me. So I can actually go here and take from the handle, and I'm going to remove that help. And I'm just going to return an empty string. So when I do that, it's actually going to remove help from the end of this handle string. In addition to that, I'm actually going to go here, and because we have a consistent parameter that we can go through, we can actually remove this underscore. We can split the column by that underscore. So we're going to go here, do a custom underscore, and we're going to split out handle. And so this is company name. And then this is going to be our country. All right, so now we have our social sentiment broken out. We have the handle, and then we also have the company name and your country code broken out here. So we can easily identify what country we're getting information from. And now we can go ahead and put that into another data set, which we'll use to combine into our main data set that we'll go through and look at the big picture of what we're looking at. So in addition to using the replace text to just break out a social media handle, there's a ton of use cases of where you might want to parse out text into various different formats. Key examples of that might be using regular expressions to identify specific naming conventions and keep that continuity, but still being able to group that data together. In addition to that, depending on what your use case is for the data, reference sheets can be incredibly useful for scaling that data. Depending on what your use case is for the data, if you want to use an ISO value versus a spelled out country name, having that reference table together is super useful, because then you can go in and tie in values like maybe you want to look at region, or maybe you just want to have that consistent naming convention, which is really useful when you're looking to improve scalability. Which brings us to the next topic, which is really just building to scale. Similar to our discussion around country codes, there's a ton of different aspects of your data that you may want to really utilize for scale. I mentioned reference sheets in regards to country codes, but there's a lot of other use cases where you may want to use a reference sheet. Going into Magic ETL is great for making edits to a couple of pieces of data, but when you have large data sets with many different options, using a reference sheet is going to be much more scalable. This is useful for SKUs, for product IDs, for feature listings, or a variety of different aspects of your data. Using a reference sheet allows you to make a change to just one single sheet without having to go in and make a ton of changes to your Magic ETL. In addition to using reference sheets, recursive data flows, like the one we showed earlier, are really useful for looking at large, constantly changing data sets. What's meant by this is if you have a data set connected from a tool that maybe has a slower load time, being able to look at just a fraction of that data, perhaps that's just like the information that's been updated in the past hour, and really looping that in with your existing data allows you to understand a large data set without having to wait for the delay of that tool to populate the data. In addition to all of the different tactics we talked about earlier, consistent naming conventions are really critical when you're going to scale for different users. It's important to note that as a person that's going through and building these data sets, a name might seem incredibly intuitive to you, but to users that are not as intimately familiar with the data, sometimes naming conventions can cause misunderstandings and affect the usability of that data for different audience members. And so keeping that really consistent naming convention will allow for increased scale as you share that out to different audience members. Utilizing Domo dimensions is something that is really useful for scale. Much like I talked about with reference sheets, Domo has inherent dimensions that are saved, such as zip codes, that you can reference automatically through Domo without having to go and build your own reference sheet, which is a huge time saver as you're going through and trying to develop new data sets. Now, we've gone through and talked about a lot of different mechanics in order to get a data set into one place. Conceptually, we've discussed, okay, why do we care? What's the utility in looking at this? And really, what we want to talk about is why. Why did I go through and I build this? I've put together an example here of some of the things that we talked about today, and really looking at, okay, so we have these 3 different data sets. What we're looking at right here is help requests, social sentiment, and net promoter score. And so across these 3 features that we spoke about, we're seeing some really different results depending on what we're looking at. When we're looking at our net promoter score, there's not a ton of difference between feature A, B, and C, though feature B is a little bit lower. But if we were just looking at that data in a silo, we wouldn't necessarily know that there's inherently an issue. Where we're seeing more of that pointing out that there's a problem that we're seeing is when we look at our social sentiment, which, as I mentioned, we live in a social media world. People are much more interested in sharing their opinions on what your feature or what your product is on social. They're more likely to share that information with their peers than they are to share it with you. And so looking at that social sentiment, we see that feature B has a really low social sentiment compared to the others. And that really indicates that there's something weird going on there. When we look at that overlaid with our help requests, we can see, okay, we're getting a lot more help requests about this new feature than we are for our other features. That's saying that the customers are experiencing an issue. But as I mentioned before, we were seeing a pretty baseline net promoter score, which likely means that there's an issue going on, but when they do reach out to us, we're able to help them with it. Which, having that insight into this business case allows us to understand, okay, this is a customer education thing. We can go through, look at this chart, understand if we're able to provide that assistance to the customer before they get to our customer service, they're going to have a much better experience, and they're going to have an experience more in line with that net promoter score, less like that social sentiment. So how can we make those business decisions based on these pieces of information that if we were looking at them individually, we might not have arrived at the same conclusion? Using this cohesive data set, we can easily look at this graph and see what that through line of that story is. As I mentioned, being able to look at that single cohesive data set is incredibly useful because these data sets might be managed by different teams, and having that single data set allows people from customer service and from marketing, from your operations team and your product team to see the same pieces of information and get the same insights quickly and efficiently without having to go from team member to team member to team member to go and get these individual siloed pieces of data into one single place. Once again, my name's Sierra Duncan. I'm a business analyst for Disney. Thank you so much for taking the time to listen to this presentation about how understanding that voice of the customer can drive your business forward.